Alright, another draft physics video production. DraftScience here on YouTube. So I did notice somebody had posted a link in the comments to a Bill Gates video. Posted a reference to my channel and, encouraging him to debunk me. And, that would be very nice, actually. Because to some extent, Bill goes to some effort. He makes pictures and images and all that kind of stuff. And so that's kind of good. I just don't know if he pays enough attention to what exactly somebody else is saying. Likes to quote mine them a little bit. But anyway, more importantly, Bill said something in a video about conversation, and finding, that you have to go through this idea of understanding at least the discourse part, the part that is intrinsically antagonistic. You really are fighting for one truth, in spite of what the nutty D. Hilster says. The argument is there's one reality and there's more accurate and less accurate descriptions of it. And it's just kind of silly to do this Special Olympics thing where you give everybody the gold medal. I mean, it's, we're adults. We should be able to not, we should be able to disagree in some sort of agreeable manner, in the sense that we could hate each other and despise what each other's saying and be offended by each other and all that kind of stuff. But take it like a man, so to speak, and recognize that you still have to have the conversation as long as the boundaries of conversation are reasonable. I think that's probably a good enough way to say it. I mean, I could add other examples from YouTube of different things that don't work and things that do work and blah, 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 blah. And things that appear to work but really don't work. The whole shock jock thing. Yes, you can win by just being shocking, but most of the winning part is losing, because most of it is just a watch the train wreck thing rather than a gain anything useful from it thing. But anyway, so clearly a mixed audience here of people who just wish to wish me dead, whatever, hope for failure, and the other side of physics conversation, that's always useful and done in some sort of manner that isn't conventional and within boundaries of assumptions and presumptions that might inspire a bit of thinking for a change. Anything outside of, anyway, a box that's so standard and so trivially incomplete, or whatever you want to say. I mean, it's substantially incomplete. That doesn't provide for much conversation. It's a kind of a God-done-it theory. Bent space and virtual photons. There's nowhere to go with that. But anyway, comments. I figure we'll catch up and then on to the next. Just some indication that I'm wrong. So anyway, no negative comments on this last video, which is good, and but also no counter argument, which I suppose is also good. So it's people aren't finding it easy to knock it down. They're going to have to work to do it if they're going to do it. So anyway, the acorn. This video is probably one of your best works yet. Oh, I already read that. Yeah. So there haven't been as many comments as I need. That's right. Okay. Yeah, that was the. I mean, who can't take on this general subject of the whole time dilation subject, just because it's so weakly evidenced, in terms of there's lots of evidence that velocity breaks clocks. There's not a lot of evidence that time is a dimension. So Michael Falwell, I don't know, I've been across this earlier and I don't think I liked it much, but anyway. Hi Gary, hope you're well. It was decent of you to consider the arguments being made and to concede your schoolboy error. Well, I don't know if it's a schoolboy error. I mean, it's the kind of error where you're tripped on the sidewalk. I mean, you can do that when you're 90. You can do that when you're 15. You know, it's uh, you know, I just simply what I simply didn't do is recognize that I am attempting to isolate what the force itself is doing, and when doing that, I have to concede that there's a difference between moving into something and changing it versus making something. You know, when you're producing it internally. I don't know, it's probably a better way to say that also. Anyway, we're going to revisit the subject. It's not like it's over yet. Anyway, I think it would be safe to say that the photon's interaction with atoms would be in succession. See, I don't know if it's exactly safe to say that, because the interaction is really taking place between the force bits, and the moving force bits are moving differently, okay, in the sense that they're traveling more distance one way than the other way when they're in motion. So I'm just saying that on the force level, I would still argue that it's a little more complicated to follow the bouncing ball. It's not as simple as the thing moved into the thing, just as your motion is not as simple as my hand moved. Well, no, not really. Your arm had to move, and your elbow had to, you know, lots of things had to do stuff for your hand to move. Frankly, there was just as many parts going, your hand moving this way, there's stuff going that way, yeah, but there's other stuff going that way to make it happen. I think it would be safe to say that for photons interaction, okay, it would be in succession when you consider the average 60 watt, I don't understand how this analogy is all, but anyway, consider the average 60 watt light bulb emits an estimated 180 gazillion photons per second. You know, those are good things just to point out, just to get to the density argument, just how dense the small universe is. And it sort of relates to Bill Gates' rope theory, because, you know, if you just think about one light bulb would have that many ropes going to every other atom in the universe. I mean, how you can't even calculate the ropes just from the source going out into the universe, let alone the whole universe doing it to you. You know, it's the rope theory is just silly. Anyway, I have to sneeze, I think. So I'll be back. That was a bit refreshing. Morning runs, you know, this whole early, well, kind of late to bed, early to rise kind of thing. I used to be a night person, now I'm a morning person, so I get up early, and my system finds the world worthy of an allergic reaction. Anyway, if you scale that up to a solar mass or emissions from an entire galaxy, then the amounts involved are astronomical. Well, that number's already astronomical. But anyway, moving on, I still don't know what that has to do with the subject of force velocities versus material velocities. I'm still not entirely sure if you grasp the argument. Whatever. Fuck you. Anyway, around 25 you mentioned redshift and blue shift out and vice versa. Well, I'm sorry if I made the typographical error of talking about it being blue shifted as you moved into it. That's probably what I said, but whatever. If you're moving towards something, you're going to blue shift it. You're moving away either party, then you're going to, if the distance is getting greater, it's red shift. The distance is getting shorter, it's blue shift. It's not much more complicated than that. The shift doesn't occur within the atom. Well, I would argue that the effective cause is the atom, so saying it doesn't occur within the atom, I don't know if that's got a purpose. It's the thing that's causing the shift is the motion, and you can't just say this, the place you dump the shift is the place that caused it, right? I mean, clearly it's a byproduct of the two events, collecting and dumping. And if you don't collect and you just dump, it's a different circumstance than collecting, you could argue. When either you are moving towards or away from the set frequency of light. So again, I'm still, you want to sit there and say, I'm not grasping. I would say you're not grasping that the only place that the real action happens is on the level of the force, that is the stuff moving the speed of light. And obviously the stuff moving the speed of light, as I'm arguing it still is, in the nuclear circumstance of pushing atoms and electrons around, electrons, protons, and the composite atoms are being pushed effectively by this force. And in a moving body, those forces have to travel more distance in certain directions than other directions, and it gets a little complicated. Anyway, the shift doesn't occur within the atom. The shift, whatever did that. The atom is processing the photons as a set timed rate, at a set timed rate, yes. So simply whatever frequency goes in is all that the atom can interpret. See, that's where I'd say you're completely wrong. I could obviously make a robot that could, pick up, that could catch baseballs going 40 miles an hour and walk towards the thing that's throwing them. And he could throw them, behind him at any rate he wants to. So there could obviously be mechanisms built into systems that couldn't create any kind of interpretation. So all we're saying is, yes, in the most basic interpretation, you're going to blue shift as you're walking towards the pitching machine, and you're going to redshift as you're walking away from somebody else behind the robot. And those two would be equal under the simplest diagram. But I don't have to make it that much more complicated to make it different. Anyway, the atoms can interpret, and the result is the same out. Okay, again, I guess thumbs up on it. Anyway, yeah, I understand all that, but again, the argument, I think, it goes more fundamental to the fact that these motions between the photons are always interactions at the speed of light, and there's no such thing as relative motion in that circumstance. All the interactions are collisions. I mean, theoretically, a force can't hit a force from behind, right? I mean, it's just sort of impossible for the speed of light thing to catch up with the speed of light thing. They're going the same speed. So the collisions are always an intersection of two opposite motions, and that's where it gets a little more complicated. But whatever. Again, I'll be back to the subject. After I get through the other subjects, we'll go back to that subject. I'm still working on it. Anyway, I've heard it said that light speed limit is really a maximum speed of causality. Well, it's clearly the fastest thing we can know exists. There's no evidence that anything goes faster. So I guess that would sort of make sense, but isn't it that sort of just a kind of a safe default kind of statement? I don't think there's a speed of causality. There just happens to be a speed that this force stuff moves at, and it really wouldn't matter what it is. The universe would be some mechanism that runs at that speed. I mean, if you doubled the speed of light, you could theoretically just double everything else. Maybe the size of everything would have to be half the size or something to make the same universe, but I'm just saying it's a condition, and the universe is built on that condition. So the condition of this universe is the speed of light is 3 million meters per second. Anyway, I like your model and watch all of your videos. I was wondering your ideas on anti-gravity. Well, I sort of talked about that before, but on the nuclear level, gravity is a charge phenomenon in that electrons and protons are moved primarily by these force interactions, and the electrons are moved primarily by reflections, and likewise the protons, so one force has more impact than the other force, blah blah blah. So you could argue that obviously magnetism is a kind of anti-gravity in the sense that you're concentrating the force to oppose the normal effects of gravity by taking advantage of filtering the force. So clearly we can do a lot of anti-gravity with simple magnets. You just put them on a stick and it looks anti-gravity-ish. I was wondering if you have any theories about if faster than light speed travel could be done. Thank you. Yeah, well, as stated, there's only these simple things in the universe. There's the force bits, electron force, proton force, and there's matter bits, electrons and protons. And all the force bits move the speed of light, and all the matter bits move the speed the force tells them to move. So the force forces matter to move. Matter doesn't move on its own. It's got to contain a force in balance to move, blah, 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 blah. So why would I think you could create some new kind of thing in the universe that moves faster? Or why would I think you could move force faster? There's just no way you can do it. There's no evidence that it can be done. There's no reason to think you can do it. So I guess I'm saying no, you're not going to do it. I don't think there's any reason to believe in the existence of that possibility. Your theory completely rewrites the book. Well, not my fault. But I wouldn't say that, right? I mean, the book is the evidence. And all we're really arguing about what hard conclusions can be reached from the evidence. And is it appropriate to do what physics has done, which says things like, the double slit experiment is nail in the coffin evidence of wave theory or something, when it really isn't. Just like GPS doesn't prove space is bent or that time dilates, in the sense of time is dimension that warps. It just proves a relationship between velocity and broken clocks. So that's the subject. Now, you want to try to pervert the subject into some sort of thing that I'm saying they're all wrong, 100% wrong, blah, blah, blah. I'm not saying anything close to that. I'm saying 90% of the data is good. And I'm saying that in certain circumstances, yes, their interpretations are 100% silly. Okay, yeah, they're just silly. They're silly speculation. You have a problem with your math and galaxies and you invent something called dark matter that, well, let's pretend there's a new kind of matter that doesn't reflect light and doesn't have electrons and protons and isn't made out of the same stuff and it's completely invisible and only does the one thing we need, which is makes magical gravity. I mean, yeah, that's 100% wrong to think that that's good science. That you just make an invisible man to solve your problem. I mean, it's just 100% wrong as a lawyer going into a courtroom and arguing to a jury. There was an invisible man, and he stepped on his toe in the grocery store. My client stepped on the invisible man's toe in the grocery store, and the invisible man got all pissed off. And so he set him up, and he made him look guilty. He killed the girl and he stole my client's DNA from his underwear drawer and put it on the victim, and that's what really happened. I mean, it's just as irresponsible as that. Yeah, maybe some jurors will fall for it. I mean, again, I'm sorry to insult your intelligence, but if you don't understand that physics has jumped the evidence and has drawn way too hard a conclusion based on way too soft evidence. If you can't concede that simple point, then I'm saying you're a jerk. All right? I mean, I'm not saying you have to buy every explanation I've provided, because it is called draft physics, by the way. But some of these themes, you have to concede the point that my explanation of magnetism is the only one. Do you want to show me a better one? You want to show me one that makes it more simple and more mechanical and more easy to draw than mine? Which explanation has the fewest moving parts and solves the problem the most completely? And I'm going to argue, hands down, my explanation does that. It's a solution to the puzzle, and it's the simplest one, and it's the most complete solution I've ever heard. And you tell me how that's wrong, and then you can tell me how, blah, 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 blah. But this is just sort of horseshit. I mean, you can't see this is like a straw man argument, because I'm critical of some of the rushed conclusions that physics made. I point out the key moments, right? I mean, this 1930 bullshit where they needed an excuse for the double slit and the this and that, and they just said, we're too impatient to wait for the right answer, so let's all just, wave particle duality and pretend we answered the question, when it's a completely idiotic solution to the puzzle. Anyway. Conventional science is 100% wrong. So, of course, I'm not saying that. I don't believe that modern science, which is what we're talking about, I'm sorry, that's not what we're talking about. We're talking about what the evidence reasonably allows you to speculate about and make conclusions about. So, again, fuck you, is 100% wrong. Okay, I don't believe. So, you don't believe they're 100% wrong. Well, I don't believe they're 100% wrong either. But I know they're 100% wrong when they pretend they did experiments they didn't do. I'd say that's 100% wrong. I'd say it's 100% wrong to talk about some just pure speculation for which you have zero evidence. I'd say that's 100% wrong to imply that there's some evidence indicating that that's possible or true. In the case of dark matter. Yeah, man, come on. Totally unfair, Matthew, so fuck you. Clearly some kind of silly person, little pinwheel bullshit icon. But anyway, I really appreciate how you think. Thanks. Okay, well, that's short and simple. It is amazing how eagerly downvoted many of your videos on this channel are. It's not really amazing, to tell you the truth. I am making a bold statement. Just as the other guy just points out. I mean, he's misinterpreting it. But I'm challenging authority and doing it aggressively. And my native personality is impatient and snarky. So it's not that surprising that some little petty people can't handle it and have to react, in a petty manner. I can only imagine the level of presumption. Oh, that's a weird thing to say, presumption. This is really not. I mean, it's the level of fanaticism. You could argue that. I mean, they're so devoted to dark matter that they have to protect it from criticism. Oh, they're so devoted to defend space. They so love Einstein's, fuzzy hair or something, or whatever the thing is they're in love with. Whatever it is they're feeling defensive about. So I don't know why somebody could get all that defensive about stuff that, again, I'm just going to argue is sort of silly on its face. Alright, so then he adds, have you considered simulating this computationally? Yes, well, I have in the past, actually, but I didn't have enough, pieces. And the other part is I really can't do it well enough. I mean, I was trying to use kind of a crude resource, HTML pages. I was actually doing it with text in the first version. Just manipulating letters, because you can move them fairly fast on a web page. I have to, this HTML5 does give you a whole bunch of options, but it's a learning curve to learn how to use it. So I've done in the past shown some stuff that's close, with the magnet, the black and red stuff goes in and it comes out black on one end and red on the other, and some little bits. But yes, it needs to be a much more precise, just pump the math in, so to speak. And it's close to being real doable, because all you have to do is fudge some of the variables, like how much does one photon move an electron, how much does it change its momentum, does it gain a substantial amount of momentum per photon hit, what's the speed difference, those kind of things. And that's the great thing of doing a simulation That's the value simulations have, not in making something, faking what a black hole looks like. It's not too good to do it that way. But simulations you can use them when you have 9 out of 10 of the variables and you're looking for the other variable. The simulation can essentially tell you what the other variable is, because as you change the number, the simulation works better. So it can be really useful. I imagine it wouldn't be too hard. Yeah, it's just like I said, it's time. I know some computer science crap, but I haven't spent any time making computer simulations, so I have to learn how to basically move things so they move fast. I have to make the code efficient enough to work well, and I have no strength in that category of performance. I have to learn how to do that, and I just don't have time for learning. Anyway, in fact, I plan on doing it myself at a less busy time. Yeah, well, people made the offer in the past, and it's always when I have the time, and they never have the time. So unfortunately, it just doesn't pan out. But it's something. It's always in the back of my head that I want to get this. I want to do it, but it's because that would really be, I think, once people see the little bits, and I tell them, look, I only have 4 formulas in this thing, and look at what it's doing. I just push the button and look what it's doing. It's making a universe. Alright. Thank you for all your insights. You're a good teacher. Yeah, well, teaching is just communicating, and I just don't know if I work sort of at it a little bit. I mean, obviously I don't work at the stylistic performance issues, but just attempting to make arguments. My whole life I've had the problem where, you see something, like say, look at the white wall. And it's white, it's a wall. And somebody says, what are you talking about? They're not getting it. And you're just like, well, that's a white wall, guys. And then you have to start, so you sort of start to learn how to, I can't just say white wall because somehow that doesn't fit in their brain. I have to say, look at the arrangement of bricks that are on top of each other, and you have to go through some other process to get them to you mean the wall. That kind of thing. You have to, it's a kind of dancing or something. It's some sort of thing like that. I don't like doing that. I don't like having to do this style stuff. I don't like wearing makeup, so to speak. I want to be able to do this conversation thing in some sort of natural way. Unscripted, unorchestrated. But in some sense, there has to be some orchestration. There has to be boundaries and limits. You can't just have all the people playing different songs because it would just sound like noise. So I understand there's some obligation to arrange ideas and present them in a certain sequence to make things understandable. Something like that. Anyway, MooGT3 or whatever that is. I'm kind of new to your channel, so I haven't seen all your videos. It'll take a while. But from what I understand so far, you propose that the whole universe is filled with this 2 basic subatomic particles. I'd suggest you go to the channel page and look at the Start Here videos and the subject videos. I wouldn't have just randomly hit on comment videos, for example. So, but anyway, filled with 2 kinds of basic subatomic particles. One you could call positive and the other negative. Yeah, well, again, it's just there's 2 kinds of thing. So there's things in the universe. There's nothing, the empty space, and then there's stuff. And the stuff is in 2 forms, force and matter. And the force and the matter comes in 2 varieties. So for the force, it's, you could say, plus and minus, north and south, electron force, proton force. And then the matter bits have protons and electrons. So one force is reflective to electrons, one force is reflective to protons. So there's just the 4 things. there's the two kinds of force and the two kinds of matter bit, and they have an inverse relationship to each other. The force has all the motion, it's moving the speed of light, and the matter has no motion innately, and it has to absorb it from the force. And so that's sort of the short version. One you could call positive and negative, and this two particles, by the way, is particle the correct name? Well, I don't care. I'm just saying that I call them bits now, so it just makes it simpler. The force comes in clumps. Force clumps, you want to say clumps? Lumps, you know. Corpuscles is the word Newton used. But yes, the force comes in quantized, consistently sized bullets. You know, you even use a word like that. And the targets, the electron and proton, are likewise consistently shaped or formed targets. Something like that. Anyway. Are responsible for gravity and magnetism and the nuclear force and light. Anyway, through a discerning filtering type mechanism. Well, like I said, gravity is doing the filtering, but the filtering ends up being neutral. So the filter's broken in the sense that dirt goes in and dirt comes out. Where magnetism clearly separates the dirt into black dirt and white dirt, you know, that kind of thing. The photon would be, okay, type mechanism. The photon would be a third particle, question mark. No, I mean, it's, so you really haven't watched too many of my videos if you haven't figured out this part. The only difference the photon has, the photon is the electron force, always, I think, and photons are that force at a frequency. So little pieces, you know, in consistently spaced pieces that affect electrons in a specific way that cause electricity. They cause atoms to exchange pressure, which is electricity. So that's the one we see a lot of because it moves electrons. And electrons on the outside of atoms, that's why they're easier to move, blah blah blah. You can make lots of explanations for why it has to be that that way. So, you know, the real difference is you have rays of these bits produced by different objects where energy goes in and energy comes out. Now the rays have a certain length, and if it isn't long enough, it's not going to do the electron turn. It's not going to convert the electron. It's not going to hit the electron with enough energy in the timings, you know, fast enough for the electron to bump another electron in a different atom. So it's not going to be able to transfer pressure from one atom to the other if the ray isn't big enough. If the ray is big enough, specific frequencies will cause different momentums in the electron and cause different reactions in terms of the flow of the electricity. So you'll have more, the faster the bullets, the more you'll have, because the bullets are going in, the energy is going in fast enough to prevent any rebound. And so it's all constructive storage of energy. I mean, I'm not getting into all those details, but though they were in this video, you're commenting on some of the details. So yeah, so photon is exactly the same stuff. There's only two things you can do to the stuff, the force. Alright, it's this black and white little beads. And there's two things you can do to it. Or maybe three or four, but anyway, there's two that are important. One is you can separate the black from the red, black from the white. And the second one is you can take the beads and shoot them at a sequence. And if you do that, it's especially, the electrons are especially sensitive to doing that. Okay, that would be how I'd say it, I suppose. The photon would be a third particle. No. What about the other subatomic particles from standard model like neutrino and muons, etc.? Well, muons are just electrons that are going faster, in the sense they have a greater mass because they have more momentum. So you could argue, nah, Muon, I don't know, maybe not. And neutrino, I know, I'd say there's no evidence of this thing. Okay, this is as a particle. There's evidence that there's clumps of force, okay, that are smaller than an electron, for example. So an electron can have a momentum, and it only gets it from force imposing it. Or you can just measure the force of the ray itself. So you can confuse that with being a photon. So let's say I had a ray that was long, but it was more than one frequency. They were not spaced evenly. Well, it might not affect an electron in the sense it might not create electricity, but it would clearly have an impact, as a force. And so they're calling these little bits of extra force that exist in the universe, and they're giving them funny names, but they're really just clumps of force, arrangements of force. And they're not really particles in the sense they're not durable structures like an electron or a proton. So I'd say they were just they're too quick to name something that is composite. It's not elemental. I'd say electrons and protons have become elemental in the sense that they're really hard to destroy. The rest of this stuff is really easy for it to dissipate into force. So I'd say I don't take any of the modern particles seriously as actual particles, because they're not even seen as actual particles. But whatever. What would you say is happening in a cloud chamber used in particle detection? What would you say is happening? Isn't it an insanely energetic event, realistically, to think that we're watching a trail of photons being released? And as the other guy pointed out, a simple light bulb produces 180 gazillion of the photons. So just imagine how many photons are being created in a cloud chamber, okay, in terms of the fact that we're seeing whole atoms being manipulated. And generally speaking, it's reflected light that we're seeing, the traces, off of whole atoms being moved. But it's quite a bit of light, so there's quite a bit of surface the lights are bouncing off of for us to see the little streak. A lot of atoms had to move for that to happen. So these things can't, they have to have an awful high energy to even be doing this tracing through an atomic structure. Let's see how else to put that. I mean, clearly electricity does that, but again, electricity, when you're producing that 180 gazillion photons from a light bulb, that's how many had to travel through the wire. Okay, more than that travel through the wire, because some of the photons you're not seeing because they're invisible and they're heat. So, I mean, it's an insane number of little bits that create everything that we see. How else to say it? So, I mean, but what you're seeing in a cloud chamber obviously is like saying, well, I'm seeing the laser beam, when it's shooting through smoke. When really the photons you see are the photons that are no longer in the beam, They never go to the target. They go to your eye instead. So you're not even seeing the true path of that photon. But you're seeing it in the sense you're saying, well, it's going from here to there. Well, not the photons you saw. They didn't go from here to there. So it's a little bit subtle complications here. So I don't know what you want me to. How do you want me to answer your question? I don't think it's a very useful question. No, just don't. What you see in the cloud chamber is, yes, you see particles losing velocity, and that should be a giveaway of something right there. They could be losing velocity because they have to plow through a lot of clouds. But we know that some of these particles just went through a 1/4 inch of lead, so why would a little bit of gas bother them? But it's hardly something, like I said, they're drawing hard conclusions on what the evidence indicates, and I'm just saying it's evidence, but it's not really a photograph. I like your proposal much better than the one from Bill Gaty. Well, that doesn't say anything at all, right? That's like saying I like your proposal better than the one the baby, pooed in his diaper the other day. You know, I'm just saying Bill Gates' theory is so ludicrous. Just not. I'm like I said. I'm just saying rope. You mean threads? Twisted threads. That and every single atomic particle is somehow sending threads to every other single atomic particle in the universe. It's and the ropes don't just get all tangled and fuck it. It doesn't work at all. Somehow they stretch and they pull and it doesn't matter. I have a bunch of threads to all kinds of other things, and somehow the only one that twists is one between me and that other little tiny atom over there, even though I have threads going to all the other it just doesn't make any sense. It's, I think Bill Gates is kind of a smart guy, but I just, I guess everybody has a crazy button, and somebody hit his crazy button, and he has just this one crazy idea. I don't know if it's his only crazy idea, but it's a pretty crazy one, because he felt into the subtle trap of the magnetic field shape. Well, they all fall into, like I said, that's just the way physics is taught, unfortunately. They always imply that these stupid lines are real, in the sense that they're somehow mathematically precise when they're not. It just depends on how many iron filings you throw down and how small they are, and a lot of things will decide where they'll end up lining up. They're lining up, they're not moving. They're not, you put the iron filings down, the iron filings aren't flowing. They're not indicating there's any motion in there, that those are highways. There's no highways. Alright, magnetic field shape that you describe quite well here. Yes, I'm just saying it's such a huge misinterpretation of what the real lines they should be drawing. The real lines are, like I said, it happens in a tank. So if you put little bits of iron in some sort of oil, some kind of thick fluid, so they don't move too fast, and then you put a magnet in there, you'll just see all the little magnetic pieces will line up north south and create a bunch of reverse kind of magnets. And that's why the magnets always the lines always repel each other. That's why there's lines. If the magnet wasn't a reverse, that is, they're all the same, they all have the same alignment, so the sames repel. So that's why they all repel each other. That's why there's lines at all. But they're clearly just going into the magnet, head first, which seems quite sensible. But once they become attached to each other, they become a bigger and bigger magnet, and that bigger magnet does certain rules. And the rule is the magnets can't be close to each other. But that's what that's the real diagram. It's a radial force magnetism. It has nothing to do with these lines on the side. There's nothing. That's just measuring the strength of the field at locations, and it has nothing to do with what's causing the field. What's causing the field is the light bulb effect or the sun effect, where you have rays of force. Magnets produce rays of force, not field lines. Anyway, alright, so I think that's probably enough. See if there's anything new or interesting or something. So yes, people want to keep talking to Bill Gates. I'd like to talk to Bill Gates because I think it would be interesting, but I'll talk to anybody about physics who has some. Bill Gates has obviously done research. He has knowledge on the subject. And so I'm pretty sure he really should. He says things that are just stupid. No particle theory can do this. No particle can, of course it can. Well, not of course, but he doesn't really provide there to be the opportunity to do that, but it can be done. And his own theory is so, like I said, just simple things. He keeps showing the image of putting a rope around a donkey's neck and pulling it towards you, and not realizing that obviously you're pushing the donkey, you're pushing on the back of his neck. There's no pull. Anyway, so that would be People need to do this interacting thing to challenge each other. See, I saw this even here. It was stupid. This Science and Energy and Technology conference thing. You know, the one that Ken Wheeler went to last year. You know, these free energy nutters. But they were talking about something, and it was funny. The guy was talking about they had to have some sort of magic water that does magic stuff. And he was talking about the fact that, oh yeah, I almost got electrocuted, and where did that come from, and how that, and you're just like, haven't you heard of Leyden jars? I mean, you know, the fact that water will hold charge on its surface is, you know, that Benjamin Franklin was doing that stuff, and I was just surprised because all these guys seem pretty deep into their, you know, doing science thing, and that's just such. You know, that's just such rudimentary and basic to an understanding of electrodynamics and electricity, is understanding the history of it. And, you know, Leyden jars were a huge advance in battery technology, if you want to call it that, or even capacitors. These people are obsessed with capacitors. I mean, the Leyden jar was basically a capacitor, you know, that you could use as a battery. And, I'm just... You're just like, well, I mean, the one form of the Leyden jar is a jar inside of a jar. It's not, they don't bother with the water, but the original version is water, is the second surface. But yeah, just surprising that they're surprised that water holds charge. I mean, how can you be surprised? That water is a dielectric, essentially. Anyway. So, stuff like that does surprise you. Sure, I guess that's all, folks. But they all are nuts. People are just nuts. They think they can... you know, it's all this wishful thinking. You know, it's just electrocute you and that'll cure your cancer, and, you know, we can have energy forever and blah, blah, blah. I mean, I was thinking about energy the other day, just because, you know, the millions of cars on the street here and all this stuff, and you're just saying... I mean, it's unimaginable the amount of fuel burned in a day on Earth by human beings. You're just trying to, holy shit. You know, we already have almost free energy in the sense that, you know, for whatever, $2 a day, people are moving their, you know, 2,000-pound car all over the frickin' place. You know, just an amazing amount of movement taking place. So cheap. You know, and people want free energy. It's just, anyway, what would they do with it? I mean, we're just thinking of the mess they'd make with free energy. They'd have stuff moving, although, you know, there'd be even more stuff moving, which is, you know, more stuff flying over your head and all this crap. So, yeah, let's hope they don't find that one. Free condoms, okay? No. Free energy isn't the solution. Free condoms, I'm just trying to think of some better solution, like surgically attached condoms at birth or something, you know, or, you know, vagina plugs. That's the solution. Ovary crackers. Yeah, so some way you can just, cracked it, it's broken. Broke it, broke your ovary. Microwave oven, maybe. Anyway, but yeah, it's gotta stop that. A better life through fewer humans. That's the solution. Anyway, till the next time, and such, and so forth and whatnot. Especially the asshole variety. Way too many of those. So anyway, get out of here before I offend someone. Oh my God. It was offensive again, and he hurted my feelings.